Assalamu alaikum, this is 191017 Yasir Zahid. I'll be explaining this question number 2 we were given in the task. So what basically we are supposed to do with this task is, if we are given, we type an even number using this keypad, we will add 1, make it odd, and then at the second stage we are supposed to make it back to even if it was made odd, and if it was odd it stays odd all the way around. So what we are doing is encoding all the even numbers as their next odd number, and then decoding them back only if they were encoded. So I will just quickly explain how I made this keypad thing, because it's a lengthy circuit, so I would like to explain it separately. Now coming to how I made this keypad, what we normally do is we use this IC, and we supply with this IC here we supply on this IC using this keypad, and we get the 4 binary outputs, the BCD outputs. But the problem here was we were not getting our required BCD outputs using this IC that's named MM74C922. So we just wanted to iterate these 16 outputs we were getting right here to get the 16 outputs we wanted right here. So to iterate each bit, we had to make, since it's a 16 number, so we were supposed to use an 8-bit. So we used 4 8-bit muxes to translate each bit. One mux is translating each bit for this LCD. Now coming to how I did that, we'll just quickly go through the theoretical part. Now when I pressed 1 I got this, when I pressed 2 I got this, when I pressed 0 I got this, for 1 I got this, 2 I got this, and I was not supposed to get this. I was supposed to get this as 0 1 2 3 4. So I have just written down what I was getting and what I wanted here in front of each other, and above here I have written the general the representation I am using for the respective numbers. You can say for example, for 10 it's plus, it's supposed to be A. When I press plus, it will be represented as A. When I press minus, it will be B. Multiply will be C, divide will be D, C will be when I press clear, it will be E, and equal to will write F on screen. So now coming to how it works, so we just rearranged the getting pattern. Since these are 16 numbers, but this side is arranged and this is not. So we arranged this unarranged side from 0 to 15. Hence our getting part is arranged now, and what we want is not arranged, but we have to arrange the getting part to use the technique I am using right here. Then what I did is I wrote the counting from 0 to 16, 0 to 15 4 times. Since we have 4 functions, these are 4 rows, right? 1 2 3 4. We want 4 in return of 4. So what we will be doing, we won't be using these last 3 bits which are B, C and D, but we will be using only A to play with the output we get from the mux. We will supply the B, C and D at the selecting lines of the mux, and we will use only this first output for our selection. Now I have wrote this counting 0 to 15 4 times, and here I have supplied A dash, here I have supplied A. So, and here I have supplied the input number, the pin which we will be selecting, and then what I have done is I have using this pattern, like here we have 5 ones, this random pattern that was made because of arranging this side, 5 ones, 3 zeros, then again 1. I did the same and I circled the 5 numbers, then I did not circle the next 3 as it was 0, again 1 0 0 1. The whole arrangement that I was getting there, I made this here by circling. Now how this works is, if both of them are circled, we are supposed to give 1 at that pin. If only one of them is circled, we are supposed to give only that. If only A dash, then A dash. If only A, then A. And if none of them is circled, we will be giving here 0. Now the patterns we get here, 1 A dash 1 A dash 0 0 A, this is the pattern I will be using as input on the pins of my 8:1 mux. This is the pattern for 8 pins. Now for the first mux, for the second mux, for the third mux, and for the fourth mux, using the first, the second, the third and the fourth function, I have arranged everything. So these are the inputs I will be supplying to my muxes. Now if I can show you here, I will just zoom in a bit. Let me be quick. Okay, now these are the 8 inputs as I got there. 9 means 1, an means a dash, and 0 means 0, 1 means 1. I've used the input to get the output I wanted. I have not touched B, C, D. As I said, I supplied them directly to each mux 2, 3, 4, 2, 3, 4, and I have only played with these 8 pins, in each of the mux. Now each mux, as I said, is translating 1 bit, and as a result we get these whole 16 bits translated to our required form. I will quickly demonstrate the keypad. So here you can see I am getting 0 for 0, 1 for 1, 2 for 2, 3 for 3, 4 for 4, 4 for 4, 5 for 5, 6 for 6, 7 for 7, 7 for 7, 8 for 8, 9 for 9, 10 as A, B, C, D, E and F. As I had decided the pattern above here in the paperwork, we are getting the same output as I had written here. So now coming to the question, how it's done. In first stage we are adding 1, and in the next stage we are subtracting 1. This is the adder IC I have used. We are supposed to add 1. Now coming to its theoretical aspect, we are supposed to add 1 only if the initial number was even. If the initial number was even, the fourth bit is always 0, so we make it not and it's become 1, and it's added in the previous number only if the number was even, and it becomes odd because we just added 1. Now in the next stage, the circuit I have used in the next stage is from our previous task we did back there. It was a 4-bit subtractor. I just iterated the circuit, just replaced some of the probes and used the circuit to meet my need, since none of the subtractor IC was working perfectly. So what I have did here in the subtraction part is, here you can see I have supplied the output from the first stage 0, 1, 2, 3 and 4. These are the bits we are getting from here, just like we have supplied here to our first LCD 0, 1, 2, 3 and 4. Okay, and these 4 final output bits of the first stage are applied here, and here I have supplied N4 again, because we are supposed to subtract 1 only if the initial number was even, and N4 is 1 only if the initial number is even, and otherwise we won't subtract anything, it will be 0, and we will get our output as final output 1, 2, 3 and 4, as final output 1, 2, 3 and 4 is supplied to this LCD. Now I will be quickly demonstrating the whole part. Now here you can see 0, 0 is even, we added to make it odd, and then it's back to even. Now 1, 1 is odd, nothing happened, it stayed 1. 2 is even, we made it odd, back to even. 3 is odd, stayed odd, even, made it odd, back to even. 5 odd, nothing happened. 6 even, made it odd, back to even. 7 is odd, stayed odd. 8 is even, so it made odd and then back to even, and 9 is odd, so nothing happened. So that's all for this video. Thank you. Allah Hafiz.